database solution, something you wouldn't normally think of an Apple product being a web database server. You've seen an announcement over the last few months from Sybase coming onto the macOS 10 platform, where they now have software up and running on macOS 10 servers, and with an Xserve it makes tremendous sense. Here is an actual database. This is the NBA's database that they serve up on the web. They have a relationship with the NBA and serve up their database. And we've brought all of that database onto, I can run it from one Xserve, and we've put a web objects front end. So there's no web server running here. It's completely accessible via the web using web objects and its direct-to-web feature in a Sybase database that it connects to, and all of that running on one Xserve. So I can drill down over the internet to a database. I can, for example, and this is the real live data, look at playoff players, see who's the leader in points per game, hit search, it goes into web objects, it queries the Sybase database, comes back with the information and presents it right there in my browser. So real web-based driven applications. I want to drill down deeper. You may notice number 9 in playoff points, Shaquille O'Neal. There he is. We can drill deeper. I picked Shaq because I think a lot of you know that he's a big iPod user. And he's convinced the entire Lakers team that they all should be iPod owners. So we're very appreciative of that. So that's an example of a database-driven website using web objects. The entire solution now, all running on macOS 10 servers, all running on Xserve hardware. I see a lot of customers starting to build capabilities like this into their enterprise. A second solution, I think this is just amazing to see, is the ability to run that BLAST software that Steve talked about that's so important in genetic research, where you compare databases of genetic sequences against known genetic code to try to find matches. It's a very computationally intense solution, and we can run that not only on an Xserve, but on clusters of Xserves. So on the back end, on this demo, it runs pretty quick. Well, let me start it off for you. I'm going to just launch it. It's going to launch a terminal script, and then on the front end is a Java application called TurboBlast for the client side, for my side, that's now sending out a bunch of sequences to a bank of 8 Xserves. Those Xservers have on them the BLAST software that Apple and Stanford and Genentech together came out with. It's called AG BLAST. That's so fast. It runs anywhere from 5 to 50 times faster, depending on word length, than Pentium-based BLAST solutions. And now we're sending out over 1,200 individual comparisons we want to do of a sequence. We have, again, a sequence here. And we're going to compare it against two chromosomes, human chromosomes. We're going to compare it against chromosome 1, and that's at the top, and chromosome X, the X chromosome, I think a lot of us know about. Chromosome 1 is actually the largest chromosome, and so it's a pretty big comparison. Yellow are base sequences that have been sent out. Green are ones that have started to come back from the server, and blue are when they're compiled into a final table and report. So it's actually going out and doing 1,200 comparisons, and it's done. It's done those. I think Guy and team will tell you that was really fast, really fast. And at the end, it brings up the final report. For those of you who are genetic experts and remember your biochemistry, you'll recognize those base pairs and the compares. We are all made up of 4 base pairs. We're a 2-bit computational engine ourselves. And that's it. What's amazing here is this is a clustered computing solution. We are right now at Apple talking to a bank of servers, running software that businesses rely on every single day, and we put together a scientific computing example that's real cluster-based computing. That is incredibly exciting that these machines are so affordable and so scalable to do real serious work like that. Okay, a couple more demos. Let's move on to an example from our publishing customers. We have some very large companies. Steve mentioned a few, Disney and others, Hallmark, so many others that are publishing based. And in fact, I challenge you to find a Fortune 500 company that doesn't have a publishing organization inside it. And here's one of our publishing developers that makes server-side software. Canto, their Cumulus product, is a database-driven product for publishing companies. So I'm going to go into this database. Now this one has an X server running a database and a Apache web server to create this front end. I'm going to go in and say, let's say I want a picture of from the Paris to Dakar races, and it's gone and queried a database of 150,000 images that fast, and I can find the matches to my query for Dakar, and there are the images. Let's say I wanted to order one. Let's go find some information on it first. I click, it drills down deeper, and brings up the information about that photo, its availability, its copyright information. I can decide to use it or not. So existing solutions that were server-driven now make tremendous sense with our new Xserve product and macOS 10 server. Okay, I have one last example, probably my favorite, most fun one. I'm going to do a QuickTime streaming demo off of one Xserve, and what we're going to do is serve up some DSL quality streams and play that, and then use a box called a web avalanche, for those who know this, that is able to simultaneously pull a lot of streams off a server to test its workload. And so we're going to start a QuickTime stream here. Again, it's a, start this one. It's a DSL stream of a music video. I'm going to connect up to that server, start playing it. And now we're playing a DSL quality stream over 0.5 megabit per second bandwidth required. And I'm going to launch my browser again, and I'm going to go to the QuickTime server management page and start looking at this stream. And what we're doing is this web avalanche is starting to run a script. See, the one stream that we've asked for is coming off of it. And then the web avalanche is going to start sending other users to it. And we're going to simulate driving, takes a few seconds to get it kicked up, driving more than one stream off this one new server. So again, we'll give it about a 30-second head start. There we go. So it's now hooked up 16 users, 67 users, all pulling data actually off the Xserve. Over 100 users now of DSL quality video coming from this one Xserve. Over 200 streams coming off this one server. Now over 300. When will it stop?